Hey everyone, and welcome back to the channel. Ever looked up at the night sky and wondered why our solar system is such a beautifully organized, yet sometimes quirky place? Specifically, have you ever thought about why planets spin the way they do, or why some of them are tilted so dramatically? It's not just a random cosmic dance, there's a fascinating science behind it all, and today, we're diving deep into the 9 key factors that shape planetary rotation and tilt. Trust me, it's a wild ride through billions of years of cosmic history. Let's kick things off with the grand beginning, the solar nebula. Imagine a massive, swirling cloud of gas and dust. This cloud, our very own solar nebula, started to collapse under its own gravity, and as it did, it began to spin. This initial spin, driven by the conservation of angular momentum, a fundamental law of physics, meant that everything forming within it inherited that spin. Think of an ice skater pulling their arms in. They spin faster. Similarly, as the nebula contracted, it spun up. This foundational rotation largely dictates why most planets, including our Earth and even the Sun itself, rotate and orbit in the same direction. If you were to look down from above the Sun's North Pole, you'd see almost everything moving counterclockwise, or what we call prograde. It's the original cosmic blueprint. This initial consistency is why our solar system generally feels so orderly. But as you'll soon see, there are some spectacular exceptions. Next up, let's talk about how planets actually formed, through a process called accretion. This wasn't some gentle, neat assembly line. It was a chaotic, spectacular process of growth. Imagine countless smaller rocky and icy bodies, called planetesimals, constantly colliding and merging together. Each impact added more material to the growing protoplanet. Now, here's where things get interesting. These collisions weren't always perfectly head-on. They weren't always aligned in a neat, symmetrical way. Sometimes a planetesimal would hit off center, or come in at a weird angle. Each one of these impacts imparted a little bit of spin, or a slight nudge to the tilt of the nascent planet. Think of a billiards game where each shot influences the ball's spin. Over millions of years, these cumulative, often random, impacts from countless smaller bodies contributed to the final rotation rate and axial tilt that a planet ended up with. It's a testament to the sheer number of events that built our worlds. But what about the really dramatic tilts, or even planets spinning backward? For those extreme cases, we have to talk about the most significant, and frankly, most dramatic factor: major impacts. We're not talking about a small rock hitting a planet. We're talking about massive, cataclysmic collisions. Picture a protoplanet the size of Mars smashing into a growing Earth or Uranus, and doing so not head-on, but with a massive, off-center impact. These kinds of late-stage, colossal collisions could have fundamentally altered a planet's rotation axis, even reversing its spin entirely. It's like hitting a spinning top with a baseball bat. You can change its entire orientation in a single, powerful blow. These cosmic billiards events are theorized to be the prime suspects for some of the most bizarre rotational behaviors in our solar system. They're the universe's way of saying, expect the unexpected. Let's look at a prime example of such a dramatic event: Venus. Our scorching hot neighbor is famous for a couple of quirks. First, it rotates incredibly slowly. A Venusian day is actually longer than its year. Second, and even stranger, it rotates backward. Yes, while most planets spin counterclockwise, Venus spins clockwise, which we call retrograde rotation. What could cause such a reversal? The leading theory points to one or more massive impacts during its formative years. Imagine a giant object hitting Venus with just the right amount of force and angle to literally flip its rotation. Another fascinating idea suggests a more complex scenario, where a combination of these early impacts and the intense atmospheric drag from its incredibly thick, dense atmosphere, along with tidal forces, work together over eons to eventually reverse its spin. Either way, Venus is a cosmic anomaly that continues to challenge our understanding. Imagine a gigantic body, perhaps even an Earth-sized object, slamming into Uranus with such force that it literally knocked the entire planet onto its side. This wasn't a gentle nudge. It was a cosmic knockout punch. This extreme tilt gives Uranus incredibly long extreme seasons, where one pole can face the sun for decades, followed by decades of darkness. It's a truly unique world. Moving on from impacts, let's talk about the more subtle but equally powerful influences, tidal forces. We often think of tides as something that happens to our oceans, pulled by the moon, but gravity works on entire planetary bodies too. Tidal forces are the differential gravitational pull exerted by a large body, like a star or a giant moon, on different sides of a planet. For instance, our own moon gradually slows Earth's spin, making our days slightly longer over millions of years. It's a tiny effect, but it's constant. For a planet like Mercury, which is incredibly close to the Sun, these tidal forces are immense. The Sun's strong gravitational tug has locked Mercury's spin into a unique resonance with its orbit. For every 2 orbits around the Sun, Mercury completes exactly 3 rotations. This isn't a tilt, but a direct shaping of its rotational period, a perfect dance dictated by gravity. Tidal forces are the universe's way of fine-tuning planetary motion. Beyond individual planet interactions, the entire solar system's early dynamics played a huge role. We're talking about planetary migration. In the chaotic infancy of our solar system, the giant planets, particularly Jupiter and Saturn, didn't always reside in their current orbits. Evidence suggests they migrated significantly, sometimes moving closer to the Sun and then farther out. These massive gravitational shifts, especially by Jupiter, would have sent ripples of gravitational disturbance throughout the entire young solar system. Imagine a cosmic bowling ball rolling through a lane full of pins. These gravitational interactions and migrations could have dynamically disturbed the orbits and, crucially, the spin axes of the inner, smaller planets. It's a game of cosmic billiards on the grandest scale, with giant planets reshaping the playing field for everyone else. Even after billions of years, the universe isn't static. Planets continue to be influenced by gravitational perturbations. These are the small, continuous gravitational tugs from other planets, especially the gas giants. Over incredibly long timescales, hundreds of thousands to millions of years, these constant, subtle pulls can cause the axial tilt of a planet to oscillate. Think of it like a very slow, gentle wobble. Earth's axial tilt, for example, varies between about 20.1 and 24.5 degrees over a cycle of about 41,000 years. This isn't a dramatic shift, but it's significant enough to influence our planet's climate over geological time. These small, long-term gravitational interactions show that the solar system is always subtly evolving, a testament to the enduring power of gravity. Finally, let's talk about something happening deep within a planet itself: internal mass redistribution. Planets aren't static spheres. They're dynamic worlds. Processes like the formation of a planetary core, the slow churn of mantle convection, or even massive changes like the melting and freezing of ice caps and glaciers can subtly shift the distribution of mass within a planet. Imagine our Earth, where magma moves and tectonic plates shift. If the mass inside a planet subtly moves, it can cause tiny but measurable changes in its rotational axis over geological timescales. This phenomenon is called true polar wander. It's like a slightly unbalanced spinning top that wobbles its axis as its internal mass shifts. It's a fascinating reminder that a planet's rotation isn't just set in stone. It's a living, breathing aspect of its ongoing geological story. So, from the initial spin of a cosmic cloud to colossal impacts, and from the subtle tugs of gravity to internal planetary movements, a planet's rotation and tilt are a complex tapestry woven over billions of years. While the initial tendency was for everything to spin and orbit neatly in the same direction, thanks to the flattening of the protoplanetary disk, the universe had other plans. Each planet's unique orientation tells a dramatic story of its formation and evolution. It's a cosmic ballet where every dancer has their own unique moves, shaped by a history of spectacular events and constant, subtle influences. The more we learn, the more incredible and intricate our universe becomes. Thank you so much for joining me on this incredible journey through the cosmos. If you found this dive into planetary spins and tilts as fascinating as I do, please hit that like button, share this video with your fellow space enthusiasts, and don't forget to subscribe for more cosmic adventures. Your support means the world to me and helps this channel grow. See you in the next video.